Hey guys, my name is Chelsea. You guys haven't seen me before. This is my first video for this semester. But it's nice to meet you all. Okay, so what we're gonna go over today is we're gonna go over acid-base chemistry, right? So acid-base chemistry, we know that when an acid and a base react with each other, they're gonna make salt and water, right? So I kind of want to get into the details of these things only so you guys can like really understand what's going on. But I also want to point out that an acid-base reaction is just a double displacement reaction. And we'll see kind of more as I keep explaining how to do this, right? So, okay, first of all, let's break up our ions. So for HBr or hydrobromic acid, we're going to break this apart to find our actual ions that made up this compound, right? So we're going to say, okay, well, according to the butterfly method, to find my charges, we have H plus, right, or our hydrogen ion, and then we have Br minus, or our bromide ion. And I found those charges based off of the butterfly method, but you can also find them in the periodic table. I erased a little too much. Okay, so now we're going to look at lithium hydroxide, right? So we're going to say, okay, well, let me break up this one. So with lithium hydroxide, we're going to have our lithium ion, which of course, according to the butterfly method or the periodic table, is a plus. And then we have also this hydroxide ion, which this is a polyatomic ion, so you're not going to find it on the periodic table, but it's commonly known as hydroxide with a negative charge, right? And then we know that this one is our acid. Hydrobromic acid is our acid because of this hydrogen. And then lithium hydroxide is our base because of this hydroxide, right? So, okay, whenever we're looking at these reactions, we're going to remember that these are double displacement reactions, right? So we're going to have AB plus CD, and then we're going to look at what products it makes. So for AB, we have our cation and our anion. For CD, we have our cation and our anion, which is exactly what we see up here. Cation, anion, right? And then we're going to say, okay, well, in a double displacement reaction, all that's going to happen is our cation is going to go with our other anion. And then same with the other thing. Actually, we start here. Our cation would go with our anion, right? So then if we look at our products, we're going to say, okay, well, these two switch together, which means this is AD plus, and then we're going to write our cation first, right? So we're going to say our cation to our other anion, which is CB. So that's how these reactions are going to work. So now that I kind of showed you in a little example, let's actually do that for this reaction up here. So we're going to say, okay, our cation is going to go with our other anion. So these two are going to go together. So you have hydroxide plus hydrogen, which means you're going to make your water, right? And we see that up here in our acid-base reaction. Then we're going to say, okay, well, what's our other product? Well, we're going to have our other cation go with our other anion. So these two are going to pair up together. And then, of course, you're going to list your cation first. So you're going to say, okay, I have this plus lithium bromide. So we know that this is our salt. And we know it's our salt because the salt is basically just a cation and an anion together. It's just like the remnants that you would get, right? The LiBr. It's just a cation and anion together, so it's a salt. Or two charged particles together, I should say. So yeah, that's how you do the reaction. And I'll come back with you guys on how to do actual practice problems with acid base. So I'll see you soon.